Hi friends, welcome to Math Guru. In this video, we are going to talk about the functions of one variable. This is the third video of our series, short notes on IIT JAM mathematics. And firstly, we learn some logarithmic properties. So this is the basic definition of logarithm. Log base a, b equal to x if and only if a raised to x equal to b. This is some formulas of logarithms. The change base of formula is some important. Like we use this usually in problems everywhere, not only in these functions of one variable, everywhere. Limit of a function. This is a basic definition of limit of a function. Limit extends to p f of x equal to L. For every real number epsilon greater than 0, there exists a real number delta greater than 0 such that for all real x, 0 less than x minus p less than delta implies f of x less than minus L less than epsilon. This is a limit definition. Limit of a function x is if and only if left hand limit and the right hand limit are equal. It means that when x approaches from the left side and the right side, the limit must be equal. Then only limit can exist. And if exists, limit is unique. This is a definition of continuity. Continuity just means that the curve is unbroken or without discontinuity. And it definition says that limit of a function at a point A is equal to the value of the function at that point. Then the function is continuous. This is some properties of limit. Nothing special, just telling. Okay. Then some formulas of limit. We can find this using L'Hospital rule, but it is good if you memorize it. Then a function is continuous in a closed and bounded interval AB. Then function is bounded in AB. The value function is also bounded in the interval AB. F inverse is also continuous if f from AB closed interval AB to R is 1 1. Then function is said to be uniformly continuous. Uniform continuity is the kind of continuity defined on an interval, not at a particular point, is considered all the interval. And its definition is like that epsilon greater than 0, then there exists delta greater than 0 whenever xy belongs to the domain. Then x minus y, mod x minus y less than delta implies mod x, f of x minus f of y delta less than epsilon. This is sequence definition of uniform continuous function using the sequence of functions. And f from closed interval AB to R is continuous, then f is uniformly continuous. Like the domain is closed and bounded, then the function is uniformly continuous if the function is just continuous. And every uniform continuous functions are continuous, but converse is not true. Like periodic functions from R to R is bounded, then it is continuous, but other functions from R to R is not really uniformly continuous. This is the definition of derivative. Function f of x with respect to x is denoted as f prime of x and defined as limit h tends to 0 f of x plus h minus f of x divided by h. And if function is said to be differentiable if it is its derivative exists at all points of the domain, and if function is differentiable at point, then it is also continuous by default. Like we can derive this from this formula, but we are not doing it. And this is some basic formulas of addition, subtraction, multiplication. This is scalar multiplication. Like on differentiation, we can use if the function is product of some functions, we know that derivative. Then if a continuous one-to-one function is differentiable at x naught and f prime of x naught is the derivative x naught, then the inverse of the function f is differentiable at f of x naught, and 1 by f prime of x naught is the derivative of f inverse at f of x naught, and f prime of c greater than 0 implies f is increasing at point c, and f prime of c less than 0 implies f is decreasing at the point c. If f prime is equal to 0 at c, then f is neither increasing nor decreasing. It is called extremum point or local minima, local maxima, like that. If a function is continuous in a closed interval ab and f of a not equal to f of b, then f assumes every value between f of a and f of b. Like similar, a function is differentiable in closed interval ab and f prime of a not equal to f prime of b, then f prime assumes every value between f prime of a and f prime of b. Then this is like question delta y. Delta y means change in the function. Value of the function is given as delta f of x equal to f of x plus delta x minus f of x. Like we get questions like what is the change at the function at the point x when the value of x is changed. This is Rolle's theorem, and in real analysis is like important theorem. Like f is continuous on closed interval ab and differentiable on open interval ab, and f of a equal to f of b. That is a condition of Rolle's theorem. Then there exists a c between ab such that f dash of c equal to 0, and like this is the mean value theorem, and this is like similar condition. F is continuous on closed interval ab and differentiable on open interval ab, and there exists a c between a and b, like f prime of c equal to f of b minus f of a divided by b minus a. Then the second mean value theorem, similar conditions and two functions, and f dash of c divided by g prime of c equal to f of b minus f of a divided by g of b minus g of a. If we put g of x equal to x, then we get mean value theorem. Like this is some problems ask if the coordinates are rotated in x degrees anti-clockwise, then what is the point of c in the Rolle's theorem satisfies the function. Then we just put f dash of c equal to tan x if anti-clockwise, and f dash of c equal to tan minus x if the rotation is clockwise, instead of f dash of c equal to 0. Then we get the points. This is generalized mean value theorem. Nothing much. It is three functions. That's all. The three functions, similar conditions, all the same. And this is a determinant of a matrix equal to 0. This is Taylor's theorem. Like a function is n times differentiable at a point, then the function can be expressed as like power series, like similar thing. And Rn from R to R is called remainder in this theorem. And this is the Lagrange form of remainder. We asked a lot of questions. What is the Lagrange form of remainder for this function? Then this cauchy form of remainder. Then this is Schlomith and Roche form of remainder. Like this is direct question, no indirect question. direct question. Cauchy form of what is the Cauchy form of remainder? What is the Lagrange form of remainder? Direct questions. And this is Maclaurine series. Just replace a by 0 and h by x in the Taylor series. Then Rn is similar Lagrange form, Cauchy form, and the other important question is maximum, minimum, extremum, finding extremum point or extremum value. Like this is the theorem. Like f from I to R has a local extremum at an interior point C of I if f prime of C exists and f prime of C equal to 0. If then we find f second derivative of f, and if second derivative is less than 0, then f is maximum. If second derivative greater than 0, f is minimum. If most of the problems is solved like this, and if the second derivative is also 0, then we use the theorem like this. It is called nth derivative test, or like that. We find the derivative second and third and fourth like that until we get a non-zero derivative. If the value of no non-zero derivative we get at n equal to an odd number, then there is no extremum at that point C, and if that n is an even number, there is an extremum, and f nth derivative of f at C is less than 0, then a local maximum, and when nth derivative greater than 0, a local minimum. It's like second derivative test. Okay. And the most important rule, L'Hospital rules. Everyone knows that L'Hospital rule, and it is very useful, and I don't want to explain it. Everyone knows it. And Stolz-Cesaro theorem, it is useful in some particular case. Not everywhere, but it is also useful if you want to score a better rank. And that's all. This is enough for getting into IIT. Thank you.